Lesson 1, Roots. So the following is a radical. The whole thing is called a radical. This is your radical sign. The number underneath the radical sign is called the radicand. I know it sounds like a Pokemon, but that's what it's called. This is called your index. And this is called your coefficient. And the entire thing is called a radical. That's radical. Yeah. So one thing that I want you to just make a note of on the side right now is sometimes you'll have a root, like the root of 3, and there'll be no n value. If there's no n, it's the same as 2. So just make that quick little note, because we already know that it's a square root, so square means 2. Okay, so the following chart is a square number chart and a cube number chart. So all that means is if you take 2 and you times it by itself is 4. So this is your x squared. So 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. The second is our x cubed. So 2 cubed, so 2 times 2 times 2 is 8. So that's all that means. Now, when we're evaluating radicals, you can do them if they're perfect or square or cube, you can do them in your head. But if they're not perfect square or perfect cube, you have to use your calculator. And you can always use your calculator, so that's a good way to check. So if you have an iPhone or a Texas Instrument and some other calculators, this is what you're going to type in. So you take your radicand, second function or shift, it depends on your calculator, yx, then your index. If you have a sharp calculator, the white ones, it's backwards. So you do your index, then this, second function yx, then your radicand. So when we do the next few questions, I want you to figure out which way you have to type it with your calculator and write that down on the page so you don't forget. If you can't get it to work with your calculator, you need to ask me so I can show you how to do it. So for the first 3 questions, we have the root of 25, the root of 81, and the root of x squared. Our n, since we can't see it, is 2. So if you want to go ahead and write that in, you can, just so you remember that your index is 2. So if nothing is written, index is 2. And it might already say 2 in your books. Now what we're going to do to evaluate is first we're going to see if it's a perfect square. So 25 is a perfect square. And it's the same as saying 5 times 5. Now because we have 2 numbers under the radical, we can bring one of them out. So the square root of 5 is a 5, or 25 is 5. So because there's 2 under the radical and our index is 2, 1 5 can come out. And if you type into your calculator the square root of 25, you get 5. For the next one, 81 is a square number. You can write it as 9 times 9. Because there's 2 numbers under the radical sign, 1 can come out. The square root of x times x is the same as x squared. So we have 2 x's. Because there's 2 under the radical sign, 1 can come out. So the square root of x squared is x. If you just want to type that into a calculator, that's fine. This is how you can see why things can come out the way that they do. So for the next one, we have the cube root of 27. 27 is a perfect cube. So we can write it as 3 times 3 times 3. So because there's 3 under the radical sign and our index is 3, we can bring out a 3. So the cube root of 27 is 3. Now to type this into your calculator, if you have an iPhone or a Texas Instrument, you type 27, second function, yx 3 equals. Backwards for other calculators. And you should get 3. If you don't get 3, call me over. For the next one, we have the cube root of x cubed. So x cubed can be written as x times x times x. Because there's 3 x's under the radical, we can bring 1 out. So the cube root of x cubed is x. The square root of 7, remember no index is the same as 2. That's not a perfect square. So we're going to have to type this into your calculator. So the square root of 7, and you should get 2.646, rounded to 3 decimals. And it goes on. So that's how you evaluate that radical. So for the next one, we're going to type this into your calculator. 25, second function yx 3 equals, and you should get 2.924 rounded. If you have a different kind of calculator, it's probably the other way around. And for the last one, we're going to do our radicand, so 29, second function, yx, and our index, which is 4, equals, and you should get 2.3205. That's how you evaluate those radicals. So for the next example, we want to write as equivalent square, cube, and fourth root numbers. So 5 squared is 25. So we know that 5 is the same as the square root of 25. 5 to the power of 3, so 5 times 5 times 5 is 125. So we know that 5 is equal to the cube root of 125. So notice how the indexes are the same. And 5 to the power of 4 is 625. So 5 is equal to the fourth root of 125. Same thing for part B. So 0.5 squared is the same as 0.25. So 0.5 is equal to the square root of 0.25. 0.5 to the power of 3 is 0.125. So 0.5 is the same as the cube root of 0.125. And 0.5 to the power of 4 is 0.625. So 0.5 is equal to the fourth root of 0.625.